In this video, we'll continue talking about solving trigonometric equations. This is part 2 of a series. In this part of the video, we will look in particular at tangent and cotangent. So again, I think the best way to do this would be to start with an example. So let's say we were asked to solve this equation, tangent of x. Actually, you know what, let's call that theta. Tangent of theta equals 2. Now, tangent is different because we're looking at, if we're talking about a unit circle anyway, which we know all trigonometric functions are based on the unit circle. Say we have an angle, and let's call it theta. Tangent is the ratio between the coordinates of this point. So, tangent of theta is equal to the opposite, y over x. Or, as we also know, sine of theta over cosine of theta. Now, it's a ratio between those two sides, so what this is really saying, this 2 here, is that my height is twice the size of my base for this particular angle. So, very similar to how we did the sine and cosines of the last video, we're going to take inverse tangent of both sides for starters. So theta is going to equal inverse tangent of 2. Which if we run to our calculator, we will get that roughly theta is about 63 point, let's call it 43 degrees for now. Okay, now very similar to the sine and cosine of the last video, that may not be the only possibility. If I think about the ratio here, it's a positive 2 between the x and the y, meaning that both of the signs have to be the same. So, what if my triangle looked like this? Then both my x and my y would be negative, but this side would still be half of the height of the triangle. So it turns out with tangent, it's actually a little bit easier than sine and cosine. You don't actually have to calculate another angle, because if we think about it, this angle would be theta, which means that between the blue theta and the green line, if we go all the way here, that's 180 degrees. So tangent has this unique tendency to always be 180 degrees. So once you find one, you can literally just put plus or minus any multiple of 180 degrees, where n, in this case, would be an integer. This would ultimately be your solution. Any of those would have a ratio between your base and your height of 2. So 63.43 degrees would be the simplest, but we can also allow for the other quadrants to take play. Okay, now that we've talked about tangent, let's talk about cotangent. So the first difficulty that we have with cotangent, and by extension, which we'll talk about in the next video, secant and cosecant, is that we don't have a means to calculate cotangent on our calculator. We only have buttons for sine, cosine, and tangent. However, let's use what we know about cotangent to change this equation a little bit. If cotangent of theta equals a third, well, I can rewrite cotangent as 1 over tangent. Now, the benefit of that is I have a button for tangent on my calculator. So let's treat this tangent of theta just as one single number, as we have been. I have a fraction equal to a fraction. This is screaming proportion to me, so I think we can cross multiply. So I'm going to take 1 times 3, which is 3. Tangent of theta times 1 is tangent of theta. And now this equation looks very similar to the one we just did. Instead of a 2, it's a 3. So I would then take the inverse tangent of both sides. So theta is going to equal inverse tangent of 3. Which, if I run to my calculator, I'll get roughly 71.57 degrees. And since cotangent is the reciprocal of tangent, and I'm solving a tangent equation here, then I can just say, okay, plus or minus any multiple of 180 degrees. where n is an integer. And that would be my solution. So cotangent, turn it to a tangent, and then solve. In the next video we'll talk about secant and cosecant. For now, let's just use those to our advantage.